Hello, glad you could join us today. This is the EMP Threat Protection and Hardening webinar, part of the EarthX 2020 Training and Awareness Series. We appreciate you making time to join us. We've got an excellent panel today to cover our subject matter, and we'll get right to it. My name is John Heltzel. I'm the Director for Resilience Planning for the Electric Infrastructure Security Council. We're a 501c3 nonprofit, and our main goal is protection of the grid and overall community resilience. EarthX this year is focusing on two of the more nefarious human-made threats that we face. If you're familiar with the EarthX series, this is our fourth year of producing one of the world's largest international resilience exercises in existence. Last year, we had thousands register to play, 41 countries. This year's exercise is going to focus on EMP and a direct nation-state cyber attack. The title is EarthX 2020 What If? And we are doing a series of lead-up training events, and this is one of those to prepare us for EarthX. At the end of this webinar, I'll get a chance to talk a little bit more about the training series, but with that being said, let's go ahead and get into the meat of the matter. It's my pleasure today to introduce Mr. Frank Koza. Frank is the lead electric subsector coordinator for the council, and he's assembled an outstanding panel of people to talk about this issue from all different angles. Frank, I'll turn it over to you now.
Thanks, John. Appreciate that. And good afternoon, everyone. The way we're going to try to do this today is, first of all, I'm going to do a very brief introduction, tying back to the session that we ran on May the 24th, which was our first session on EMP. And then we want to talk about EMP testing. Chris Beck will do that. Talk about protection concepts, and Davidson Scott is here to do that. Kevin Poole is with us from Triton, and Kevin will show you some examples of enclosures that are actually being constructed and installed. And then finally, Eric Easton from Centerpoint Energy will show you what I'll call a more holistic approach to substation protection. So that's kind of the game plan and how we hope to cover the topic today. Next slide, please, John. So I think I showed this at the May 24th session, and I just wanted to mention to you, for those who may not have seen this, and just to kind of orient you to the EMP threat, most of the discussion today will be about the E1 pulse, and I'm not going to get into a detailed explanation of the chart, but it's on the left side of the chart, and you can kind of see the very, very high amplitude of threat that you get from the E1, even though it's a very, very short time frame. But that's the threat to solid state electronics that we're so concerned about relative to the power system and the other infrastructures. John, next slide, please. And this is also a slide that I used on May 24th. And obviously we're going to spend the whole time today talking about the second and third bullets here, and our speakers will address those in a lot of detail. I just wanted to mention here that the topic of prioritization is something that's important in developing an EMP response plan. And we will try to tackle that topic on an upcoming EarthX webinar that's scheduled for June 24th. So just kind of tuck that away and make a note of that for the future. John, next slide, please. So as I mentioned, we want to first talk about EMP testing. I want to introduce Chris Beck. Chris Beck is the Chief Scientist and Vice President at EIS Council. And Chris has been working with a partnership that EIS Council is involved with EMP testing. So Chris will talk about how you do testing and kind of what the initial results are telling us. Chris?
Thanks very much, Frank, and thanks everyone for joining. Next slide, please. So I want to talk about today testing that EIS itself has been involved in. There's lots of other testing out there. Important things have been done by Meditech, by the Electric Power Research Institute, and others. And we can loop back to that at another time. But just given that we have some new things going on, I wanted to talk about the partnership that we've had in doing some tests on equipment that could be damaged by HEMP E1, as Frank mentioned, and that's been a partnership with the Defense Threat Reduction Agency, DTRA, with Scientific Applications and Research Associate Sarah, along with us. It's been a very fulfilling partnership in that, especially we started working with them now about 6 years ago. We started the discussion. Sarah was kind enough to provide some expert review of our very first EMP or EPRO Handbook 1, the section on EMP and space weather. And the partnership grew from there. And we're happy to be working with these two entities, and especially thankful that the Defense Threat Reduction Agency, which normally works in a kind of classified environment and national security posture, has been very helpful in looking at how this type of information, understanding that it can be useful for civilian-owned critical infrastructures. Next slide, please. So we're going to focus today on a couple of key components that we're testing, that we have tested, and then I'm going to talk to some tests that we're looking to conduct as well. So as Frank mentioned before he introduced me, there's a couple of threats that we're worried about. The radiative threat, which is direct radiation that can impact components, and conductive threat, which is the radiation takes a secondary path. It gets into wires that then get into the components. And the two components that we're going to be talking about are the relays, which are at transmission substations, and distributed control systems. So there's kind of the front end and the back end of each of those. They perform similar functions as command, control, and protection functions. And so their behavior is actually pretty similar. And when we do the tests, we're using the MIL standard 188-125 test. Those have a characterization of the response of the device, which is either no effect, nothing bad happened, a non-latching upset, which means something gets wonky, but it self-corrects and the device keeps working, a latching upset, which means that intervention is required to get the device moving again. Maybe it's a power recycle. It could be something more, but the device isn't damaged. And then finally, the highest level is if there's actual device damage. Next slide, please. The radiative threats, the tests we do for those are called the Transverse electromagnetic cell testing. So it's basically like putting your device in a microwave and seeing what happens to it. So this is a really big microwave there. You see the copper shielding around. That's the barrier of the device. And inside, the test object is placed. You can see it there in the black rack. And if you look kind of closely on the lower, the close-up, the zoom in, there's some field detectors on there, and you can see the electric and magnetic fields are shown there. So what you have is then you would have either the relay or the DCS component will be placed in that rack, and the field level is ramped up, and we look at those, either those responsive, no response up to destroyed happens. And when we looked at the relays, they're pretty robust under this kind of test. We got to the very highest level of the test above 30 kilovolts per meter, and only had some minor disruptions. So we had a non-latching upset. And with the DCS systems, very similar results happened, got to the highest illumination levels and had non-latching upsets, but there was no destruction of equipment. Next slide, please.
There we go.
Another test that uses, we'll go to the CW test. So another test that uses radiative testing is this continuous wave test. This is an external test. It's not in the lab. And what it's not designed to stress the device to see whether it can handle it without being destroyed, but rather it is basically testing that transition from radiative to conductive. So you look at how much energy can actually get into or be coupled with the device. And with the DITRA, SARA, and EIS team, we're very fortunate to partner with Dominion Energy and do the first ever test of a power generation plant. So normally these types of tests in a military environment, they illuminate objects that are like a tank or an airplane where you can illuminate the whole object. It's very challenging to do that with a large power plant, but this was the first time this was ever attempted. We did the best we could, and it is difficult to have a very nice, tidy, closed solution when you have to sort of do partial runs this way because you can't illuminate the whole facility at once. But we did find some very important findings. This continuous wave field is very low energy, only a hundredth of a volt to 1 volt per meter, and we still found that we were noticing that energy was getting into the control cables, and the distributed control system wasn't damaged, but it was noticing that there were problems and alarms were sounding. Next slide, please. Now we're getting to the part where what happens when that energy gets into the cable, and the simulation for that is what's called pulse current injection testing. So this is a picture of that lab setup, and on the far right you see the pulsar. That is the one that will put energy into cables that are then those go into the inputs of the device under test, which would be put in that black rack in the middle on the table. And we saw that the electronics, both the relays and the DCS, were much more sensitive to these pulse current injections than they were to the radiated. Next slide, please. With the PCI test, we also wanted to test whether with a protected or an unprotected mode. And so you see, this would be kind of like a different view of that rack in the center. The object under test is in the top middle with the circle and arrows pointed to it. That would be the relay or the DCS components. And then at the bottom, there is a rack that was built by SARA, and there's a blow up of that in the lower right that shows some small input level metal oxide varistors devices there. Those are for the input ports. The one labeled number 7, that's at the AC power level, and then on the 6 is a spark gap to protect the Ethernet port. So we did see that without the protection, eventually as you ramp up to what's the maximum of 5,000 amps inject current during these tests, all the relays that we tested were destroyed. All the DCS components that we tested were destroyed. But smartly, before we did that, we tested it with the MOV device in place, and that had a much better result. There were some upsets, both non-latching and latching, but nothing was destroyed up to the very top level. When we got to 5,000 amps, we were still able to break things, even with the MOV protection in place, but it performed much better. So we know that MOV protection is an option that will work. Next slide, please. So finally, just to pull this together, the conducted threats we found through our testing are the bigger problem. So radiative tests are important. You have to address both, but don't forget about the conducted threats. And I just wanted to mention that we have some new testing that will begin next week, where rather than the slide we previously looked at where those MOV protection was at the device level, it was down at the small level of the relay or even the relay input. We're looking at Dominion. I want to give them credit, had this wonderful idea of what if we put the MOV protection not inside the control house by the relays, but out in the yard where we kind of would protect farther upstream, if you will. This will only work if we have cable that doesn't pick up that energy. So you need shielded and grounded cable. I know the details of how these protection methods will work is going to be talked to by Davidson and others. But we're very thankful for our partnership with DITRA, SARA, and also Dominion Energy for making these tests possible. And we hope to be able to share those results maybe by the end of the year or early 2021. And that's it for me, Frank. Thanks very much.
Okay, Chris, thanks very much. John, next slide, please. So with that testing understood, at least give you some basics on the testing. I've asked Davidson Scott from Electromagnetic Associates to really kind of cover the landscape in terms of protection. How do you do it? What are the things you need to think about? All of that kind of stuff. So Davidson's had a tremendous amount of experience in EMP. And so Davidson, turn it over to you.
Thank you, Frank. Good day, everyone. I'm Davidson Scott from Electromagnetic Associates, and really appreciate our host at the EIS Council for the opportunity to address you on this important topic. We're going to dive into a pretty high-level review of protection concepts, and diving right in. Really, the first step in this process is to establish the electromagnetic threats of concern, and we're going to talk primarily about HEMP, but there is intentional electromagnetic interference, IEMI, which is sort of an electromagnetic weapon device that's repurposed to do damage. And of course, there's always out there, most folks' familiarity with electromagnetic threats is usually with the Tempest and related cyber types of things. And that can be pretty complex, but I'm including it because the electromagnetics are reciprocal, and oftentimes you got to look at a blended threat, for instance, an IEMI attack and a cyber attack. So those are threats that are out there that you need to just be aware of. Next slide, please. Basically, when you're diving into this, you've got the MIL standard to guide us. That's really the first document that's out there to help evaluate this. And the military has been doing this for a number of decades, and that's embodied under the MIL standard 188-125-1-2. 1 is for fixed facilities, 2 is for mobile, and Kevin Poole will be talking about some of the modular and mobile facilities in the next presentation. But this standard is presently under revision. It's been under revision for a while, but it applies to shielding time urgent military facilities. That's time urgent, just saying that you can't afford any disruption whatsoever, so you have to use a low risk approach to make sure that everything works. And it's basically a highly conductive surface covering floor, walls, ceilings, and these are some examples. Not all of these are MIL standard compliant, but it's an example of the types of shields that you might see. They come in all shapes and sizes, and there are a lot of different ways to accomplish the goal. Next slide, please. There are also, I'll just call them civilian standards. And the EIS Council has released a number of useful handbooks, and is currently updating their EMP handbook, and hopefully that will be out soon. But they're helpful in understanding the things that you have to do to provide protection to facilities or systems that you're working with. In addition, DHS has recently released through the NCC an EMP document that's pretty useful. It has 4 EMP levels. It's not as comprehensive as it can be. It's growing and it's under revision, and hopefully it will get there. But specifically on things like IEMI, certain techniques are not covered in that. And if you want to dive into that even more, it does have a very robust references section, and I would encourage you to look at that document and the references. to look at comprehensively on what you can do for certain situations. Next slide, please. The basic concept with electromagnetic protection is understanding that, as Chris had alluded to in the previous presentation, you have radiated emissions and you have conducted emissions. And conducted emissions, you can call them, essentially they're radiated emissions that have been absorbed on a conductor, whether it's a wire or a structural piece of a piece of equipment. Those things can and do couple, but they will also re-radiate. So you've got the situation where radiated emissions and conducted emissions can trade places and often do. And so as a result, when you're looking at protection concepts, you really have to look at the radiated and the conducted together in order to achieve a robust shielded environment. In the end, most damage comes from conducted emissions that reach a semiconductor junction or some other critical component and breaks down it arcs across to create some sort of a problem or damage to a system or a component. So you have to look at radiated and conducted emissions, and it's very important. Next slide, please. So basically, radiated emissions, the way that you protect against that is you create a six-sided box, a Faraday cage, although instead of a complete Faraday cage, you have penetrations, engineered doors, air waveguides, and other things to make the box useful. But that's how radiated emissions are controlled. On the other hand, with conducted emissions, you need to go to removing energy that's imposed itself onto cables, and that's done through employing filters, MOVs, and sometimes you can do it with grounding of jacketed shields on cables. But it's important that when you're looking at this, depending on what kind of a system is connected to a cable that's coming in, it's also possible for those filters to modify the intended signals and maybe cause a problem with what you're monitoring. And so that is a very important concept. You have to understand what the filter's doing and make sure you get one that's appropriate for the application. And there are many different vendors and many different ways to do that. Next slide, please. So basically, when you're looking at protection concepts, the military systems, it's pretty simple. You have to follow the MIL standard. There are a lot of organizations and support vendors to help comply with the MIL standard protection. And ultimately, the military looks at the mission of every single facility and decides whether the protection as documented in test reports and other things is sufficient. In this for civilian systems, in some cases for critical operations, you're going to want to sort of mirror the MIL standard, but you should also look at there are other ways of enhancing your protection using redundancy, sparing. Maybe you have some procedures to work around when things fail. Maybe you have some degraded modes, manual operations. You should exercise all of these things so that they work the way that you expect them to. And indeed, some civilian systems, you simply can't protect them the way the MIL standard systems are protected. Like you can't put a Faraday cage around the entire electrical grid. Next slide, please. Looking at IEMI briefly, IEMI is different from hemp in that IEMI can be a repeated signal. It can be a much stronger signal, at least at its source, than a hemp. And so it looks, one of the recommendations that I make is that you, instead of looking at a specific shielding requirement of like 80 dB at as with hemp from 10 megahertz and higher, you look at the immunity of 3 volts per meter for shielding sensitive equipment. And this refers to EN 55035 is a relatively new standard that's adapted from 55024, which it replaced to, for IT equipment and other sorts of things. And it gives you a good view on what do you need to do to make sure that your systems are safe. And for hemp, you're trying to reach a certain shielding effectiveness. For IEMI, you're better off looking at, and this is my opinion, better off looking at the actual field levels inside of a facility. So next slide. One of the things that you can do with IEMI that you cannot do with hemp is you can look at the lines of approach. And so you can do a view shed assessment technique to help you identify where you might be vulnerable to IEMI threats, and then you can take appropriate action to limit the IEMI threat in a particular facility. And to the right there's a technical basis for that, referencing an IEC standard that shows that you can take advantage of the distance away and anything that's in between a threat system and an IEMI threat. Next slide. Basically, using a standoff distance, fences, sometimes your fences might be shielded, and also integrating your security response protocols allows you to offset some of the shielding you might require in certain circumstances on certain facilities. And so it's an important aspect that you're going to want to look at. Next slide, please. So basically, for civilian facilities, the MIL standard is important to follow. It focuses on eliminating damage, disruption, and upset. But if your facility doesn't need to be quite as robust as a MIL standard time urgent facility, you might want to adjust your standards and possibly look at a minimized damage, disruption, upset type of a posture. And that's a pretty deep technical discussion on what's the difference between that, but that's something to look at. And in IEMI, you follow hemp shielding aspects, but also take advantage of some of the IEMI unique techniques. Like IEMI generally won't penetrate very far into the ground, so you can use techniques to shield against IEMI that are not possible with hemp. Next slide, please. I'm not going to go over this in too much detail, but these are just some example shielding options that you want to look at. If you're doing a retrofit facility, oftentimes it's useful to just line it with steel. Sometimes for new facilities, that's the way that it's done. There are options like panelized mechanically fastened seams that are out there and in regular use. There are some innovations with carbon-containing concrete and tilt-up construction that have been shown to be effective. Also, the use of steel shield forms to do sort of a similar thing, but use a more conventional type of a Faraday cage in the end. And of course, you hear about exotics. Someone has a paint, a foil, or a paste that comes into play. All of these have different pros and cons, and appropriate applications and inappropriate applications. And so you've got to consider your cost and the limitations of your project and the protection posture you want to reach. The next slide, please. So bottom line is today there's more options than ever, and traditional shielding is something that's pretty tried and true. Some of the newer techniques using absorptive shielding, it can also be effective, whether it's carbon in concrete. You can even use coal ash. That's something that's being looked at today. So, or you can use a combination of both. So I appreciate your time today, and I'm going to hand it over to Kevin Poole to discuss the modules and modular shielding.
Thank you. I'd like to thank the EIS Council for allowing us to participate today, and welcome to EarthX 2020. Next slide, please. My name's Kevin Poole, Triton Defense Incorporated. We're in Hollywood, Maryland. We build EMP protection, mobile and fixed modular platforms that are highly customizable and virtually unlimited manufacturing options you could have. So I'd like to go through some of these slides and explain some of that. Next slide, please, John. So EMP shielded modules, we can manufacture SCIF, VTC, IT, command and control centers, power generation, and to whatever level you actually need. They could be fixed or mobile applications, and highly customizable. Whatever you can imagine, we could actually design, engineer, fabricate, test in-house, and deploy. Next slide, please, John. Power generation, and if you notice, these are concealed. They can look, these modules can be, a fixed module. They can look like a lawn trailer. They could be anything you actually like, but we have the ability to engineer multiple modules to create an array of modules that'll work in a field or in a building, whatever may be needed. Next slide, please. This gives you an idea of how we would build a fixed module. Interesting part about this is when I say fixed, it's really installed on a simple sonotube and concrete design on ISO blocks, similar to the way sea containers are built. But these are not sea containers. These are custom built, EMP protected. Next slide, please. So EMP shielded modules is design points I'd like to mention. They're designed to be mounted on minimal foundation, which is a sonotube design. It's fairly simple to do. All elements get HEMP protected: power, mechanical, electrical, fuel. Provides a technical space for control center workstations. Typically, these modules are under $1 million. Fuel options are diesel and propane. They can be customized in their sizes. They can be wider, longer. We just built some 12 by 20 modules. They can also be NIJ level protected. We fully engineer them, environmentally controlled. They're transportable, relocatable, CBRN air filtration options. And there's also an option for data center and configurations for technical control functions. Next slide, please. This gives you an idea of how we manufacture. Everything we build is CNC, is 3D modeled and cut on a CNC laser, tube laser, flat sheet laser, and then formed, and we build wall panels. We build all the integral P.O.Es and waveguides, and then we test the envelope and make sure we're protected. Then we'll go into a rough electrical pre-wire, and then we'll foam spray the insides. and then finish the insides and put all the equipment in. Next slide, please. This gives you an idea of some of the waveguides that we've built and P.O.Es. They can be virtually anything that you need. We can custom design a P.O.E panel to work for you. And we've had some pretty good challenges, and it's always worked out well. Next slide, please. So this is an EMP protected module that has an armor shell, NIJ level 3 protection. It's quite a challenge. We just delivered the first 2 recently. They love them. I think Davidson actually tested those in the field for the company we built them for and had great results. So any challenge, we're up for it. And we have some other armor designs coming out soon. Next slide, please. So EMP protected modules for CACI and FEMA IPAWS modernization program. These are a wonderful project we've been involved in, has power generation and broadcast. So wanted to mention that. But thank you all for today. I appreciate your time, and I'm going to pass it to Frank. Thank you, Frank.
Thank you, Kevin, and thank you, Davidson. Our last speaker is Eric Easton, and I mentioned at the beginning here, Eric is from CenterPoint Energy, and Eric's going to talk to you about a project that he led that actually resulted in what we call digital substation, and like I say, a more holistic approach to protection. So with that, I'm going to turn over to Eric. Eric?
Thank you, Frank. Yes, next slide, please. Okay. CenterPoint Energy is located in the Houston area. So we have roughly 2.5 million customers with a little over 230 substations and serve about 5,000 square miles. Next slide, please. So in 2015, we started really finishing up the EMP control center. From that, we learned quite a few lessons around what it would take to harden other assets on our system, mainly the substation control houses. After we completed the control center, we wanted to try to figure out what would be the next steps. And as I mentioned, we did have 230 plus substations, so we knew whatever we developed needed to be applicable at scale. We started by applying many of the same concepts that we had used in the control center, but we also wanted it to be multi-hazard, similar to some of the other presentations where you talk about ballistics. We've also had flooding challenges here in the Houston area and control house fires. And so we wanted to be able to develop something that was going to be applicable to all of those. Some of the challenges we saw with using the control center approach was the fact that we were going to have a building that could be expanded over time as the substation grew. And we'd also have to employ some tactics which are not very conducive in a power substation, such as high frequency grounding, which could lead to misoperations. So that shifted to a more modular approach that you'll see on the next slide, which is much more compact. It allows us to use a digital substation solution, as Frank mentioned. So we've translated everything that we were doing with metallic conductors into fiber optic cables. So that really decouples what's happening in the yard versus the equipment that's housed inside the substation control house. So the module that you see here on the left is the main module, which houses the protective relays, the SCADA systems, telecommunications equipment, etc. On the side of that is 2 sub-enclosures, which allow us to bring filtered power in and take filtered power out to the merging units that you see on the right-hand side. So in between those 2 enclosures is the fiber optic connection. And then inside the merging unit enclosure is where we house the surge suppression that's been referenced today that allows us to protect for the coupled energy that might be exposed to, the equipment might be exposed to through the instrument transformers. And so that really reduces the number of surge suppression devices that we need and it also places them as close to the beginning of the circuit as possible. Next slide, please. So when we began going from concept to fabrication, we knew that we wanted to address all of the electromagnetic threats. So that would be HEMP, IEMI, and GMD or GIC. So we wanted to be able to capture all of that within one module, but then we also wanted that to be a consistent set of hardware so that it would be scalable and repeatable. And once we had the hardware established, we could replicate that across our system with greater ease instead of having to do custom fabrication for each project. So what you see here is the finished module that's been fabricated. It's roughly a 4 foot by 4 foot footprint that fits inside of our existing control house. We decided that the Ciprotech EMP module was going to be something that with minimal modifications, really what we did is added a little bit taller door to the existing control house, and then it sat inside. So you can't tell from the outside of our substations which ones have been protected and which ones haven't been. The other thing is it prevents us from having an incidental compromise of the shield where somebody's doing other work in the control house and they drill a penetration through the control house wall and now our shield is compromised. In testing, what we were able to do was first the IEEE 299 test, which allowed us to check for shielding effectiveness. And then we also subsequently performed system level test with an unclassified E1 pulse. Both of those confirmed that we were achieving over 100 dB of attenuation. And then we also went to the step of doing direct injection testing up to 80 kV, and using the surge suppression did allow us to protect those devices. Other concerns were the fact that we had so many electronics packed inside such a small enclosure. We wanted to be able to test for internally generated noise emissions. So we did perform those tests. And then similarly, with so many components in a small enclosure, we did some thermal modeling to make sure that we weren't going to have thermal problems from the electronics being packed so tightly together. The next slide, please. So in addition to the mitigation of the radiated and coupled, we were also concerned about IEMI attacks that might be more focused on just disruption of data, where back at our control centers, our operators may see data that is incorrect due to some type of electromagnetic interference. So we installed also an IEMI detector that allows us to compare the signals that we're getting from the hardened enclosure to the signals that we're getting from our non-hardened substation infrastructure. We can do that comparison and then also monitor any magnitude and frequency of signals that we might be seeing to determine if some type of nefarious attack is underway. Next slide, please. And then the GIC detection is using a split core 4 to 20 milliamp sensor on the neutral of the auto transformers. That allows us to capture the quasi DC in real time, and then we can alarm off of that. It could be programmed to also take control actions such as opening circuit breakers to isolate transformers, but our intent right now is just to use it in a monitoring mode. Next slide, please. So here's the completed installation of the EMP module inside of the substation. As you can see, it's fitting right next to the existing lineup of panels that were in the substation, and it actually replaces what would typically be 16 individual feeder or transformer panels with one module. And the way that we're able to do that is because of the use of fiber optics. All of the spacing is much closer. And then additionally, we can do multiple protection schemes within one relay. So we still have full redundancy using multiple relays, and then the merging units themselves have some protective capability, but it allows us to shrink the size of that protection and control package while hardening it at the same time. Overall, the installation time was roughly 7 days because we're able to do pre-testing in a digital workbench and then we move into the live substation after that. Next slide, please. So in operation, what we have is the existing protection and control package there in the top middle, in parallel with the module and the hardened control package. We leave the links open on the EMP hardened. If we were to have an EMP event, we would then close in those links and we can immediately restore the substation, put it in service. Next slide, please. And then one of the last things that we did was a cost comparison. We really wanted to see what were the different options for mitigating coupled and radiated energy, and how could we achieve those with each of the different mitigation techniques that we've discussed here today. It could be a full house, it could be MOVs, it could be fiber optic conversions. At the top, you can see the module came in at around 500,000 for the application we were doing, which was about 20% of some of the comparable options. So this color code is a qualitative representation of the effectiveness of the mitigation. And then there at the bottom, we also assess the life cycle costs based on O&M for the module versus other competing alternatives. Next slide, please. And then lastly, just here in the center, we started working on a HEMP solution, which then turned into IEMI and GMD. But because of the compactness of the module and the consistent hardware, we're actually able to redeploy that for other high impact, low frequency events, such as floods, fires, ballistic events, or in doing so, we also went to the digital platform, which created a cyber concern, but we've also solved the cyber issues as well. So we think it's a very holistic approach that allows us to mitigate multiple hazards with one solution. And with that, I'll give it back to Frank.
Eric, thanks very much for that presentation. I want to thank all the presenters. We went through a lot of information with you here in a very brief period of time. I do have a resource page included here. And by the way, we will make the slides available for those who are registered. Just to review the resources page with you, on EMP testing, we are making available a report that Sarah did, that Chris talked about. There's the link for it on the ES Council website. There's the internet pages for both to get a hold of Davidson or Kevin at Triton Defense. All their information is you can access at those two pages. And then lastly, on Eric's presentation here, because Siemens is actually actively marketing that solution, we've got a link there for a Siemens information page. And if you want further information regarding that solution that Eric just went through with you, you can certainly contact the folks at Siemens. So again, I appreciate the presentations from the presenters. And at this point, I'm going to turn it back to John.
Hey, Frank, thank you. And thanks again to Kevin and Eric and Davidson and Chris for their presentations. And Frank, obviously, always for your leadership. I want to close out our session today with just some breaking information for everybody that's on. EarthX is scheduled, as we mentioned earlier, from 1 September through 31 October. We have a full series of training events that will help people get in line and get prepared for EarthX. That information is available on our website. But coming up very soon, one that we've just added to the calendar here in the last couple of weeks is an overview of the EarthX exercise itself, EarthX 2020 What If. That'll be on 18 June. If you've registered for this seminar, I'll make sure you get the registration information. And then one that we've just pulled together that we're really excited about is Metagrid Resilience. EarthX is all about protecting the grid. The Metagrid is the grid of grids. Frank mentioned it earlier. We're going to talk about a number of critical factors on what it takes to have the minimum core utility requirements met. And that will be on 24 June. So put those on your calendar and look for some updates from us coming out on how to register. This is a full series we've listed here of the upcoming and scheduled events that will be going on all the way through August, building up towards the World Status webinar. EarthX this year is taking on, as I mentioned earlier, two of the most nefarious human-made threats, EMP, which we've just learned about, and a direct cyber attack. So if you hang with us through the whole period, you'll get a chance to be part of the world's largest resilience exercise. To do that, we're actually going to jump into something today and give you a chance to give us some, what we hope is very cogent feedback from your perspective. EarthX is going to be delivered in 3 different phases. The first phase will be EMP preparedness. The second phase will be cyber, but the third phase is something we're calling the global continuity framework or the resilience framework. We have been gathering this information and these thoughts and doing some work with some of our international partners for the last couple of years. And what we've learned is that there are some very fragile points that we are connected at that truly underpin everything we do in society. And of course, just the last few months with the COVID virus has given us reason to really question some of those connection points. So what we're going to do is today is we're going to give you a chance to kind of get a start on phase 3. So we're actually going to start it now. When we conclude the webinar, you will get a link for a survey that we'd like you to complete. But what we're doing is we're using your input, all the feedback we can get from you all and our other partners, and we want to build a ramp into this new future. We want to talk about how do we address black sky class threats. That's what the EIS Council is all about. We have a tremendous number of local disasters and local emergencies, but black sky class threats, of which the COVID virus was a near black sky hit, has the ability to completely change the culture and the society as we know it. So we're going to have you a chance to give us some feedback on some questions, and we just want to know what your thoughts are. And then we'll also make sure if you return your survey, we'll get you information on how to be part of our ongoing commission series, which is going to kick off in late July. Some of these continuity areas that we've talked about are global supply chain, critical lifelines, utilities, something called the essential worker status. Obviously, food supply, if you were following the news in the United States recently, during COVID, things got a little dicey. Looks like it's going to come back, but they had the potential to go off rails a little bit. Obviously, if you're in this one, you understand the need to focus on information sharing, but we want to advance the idea about recovery areas that need to be focused on so that we can come back faster. And then one of the highlights coming out of the actual COVID threat was, how do we do a better job at alerting? How do we do a better job at understanding what's going on? And then how do we share that information? Those are just a few of the continuity areas that we're looking at. So when the webinar concludes here in just a minute, you'll get a link to some questions that'll look an awful lot like this. There aren't very many questions. They're very open-ended though. There's a couple of them that are fairly closed, but the last 4 are very wide open. We're very interested in what you saw and your thoughts were out of the international COVID event. This is one of the first disasters we've had that really has jumped between the international boundaries. And the other piece for those of us in the United States, this is the first time ever that we've had a disaster that hit all 54 states and territories. So there are some very deliberate lessons learned that we need to pay attention to and take them from lessons observed, where we just saw something that didn't work, and move them into the lessons learned and lessons applied categories. So when you get the survey, I'd be very interested. I read every one of the responses, and we will use your responses to move ourselves forward. One last thing I mentioned briefly a second ago, and that is this idea of the Resilience Commission. A number of our key partners are working with us to put together a series of webinars that will begin in July, go through the fall, that will drive us into what we're calling the International Resilience Framework. And we're going to take a look at all the threats, some of the threats that we talked about today, plus other threats, and what are the resilience actions that can be taken. And we're shifting our focus from the 5-year to 10-year process to the very tactical solutions, a lot like what Eric and Davidson talked about today, and Kevin, things that you can go and solve some of these problems today or can put into the resource chain. So stay tuned for more information coming to you from the council. And then finally, our last slide for today. I hope all you all will take a chance, and if you haven't registered for EarthX, please do. If for no other reason, the EarthX registration is how we're sending information out, so we don't spam people that don't want the information. Register at a minimum. I would hope that you would register and play as an individual and family, but most of you all are coming from an organization that believes in preparedness, believes in resilience. EarthX will give you a chance to actually do that. If you have any questions coming out of today or any questions about EarthX, please send them to the email address on the screen. It's earthx@eiscouncil.org. Very simple, and we'll get those routed to one of the panelists that has the best opportunity to answer those. And then you see the registration site for EarthX. If you haven't registered, please do. One of the things that's interesting, after 4 years, all you have to do is Google the word EarthX and our registration site will come up. So I think we finally hit critical density. And then just a word of encouragement here. Invite your friends and your family and others in your professional network to play. Something that's come to our minds recently is it really is your responsibility. You as an individual, you as a member of your organization, you as a member of your community. It's your responsibility to make sure we're prepared for these disasters because we know they're going to happen. And we need to make sure we've done all we can to survive those and be able to restore our infrastructure quickly. So help everybody be prepared. And again, I want to thank our panelists today for some outstanding presentations. As Frank mentioned, I will take the registration list and I will send a PDF copy of these slides to everybody within the next 24 hours. And then as the video is rendered, I'll make sure that the link for the video goes out too. So please register for EarthX, and thanks again for your time. You've been a great audience. And I want to, again, one more time, I want to thank our panelists. Great job, guys. And with that, we'll give you back a few minutes out of your hour. You all take care. Be safe.